All right, everyone, we are back and we are going to solve our last question on our practice exam 2, ANOVA. So we're going to be working with basically a built-in data set in R. So let's go ahead and before we get started, let's actually go and we are going to look on our canvas and we're going to download our R code for ANOVA. So let's wait, let's get our Duo authentication in. Yes, it is me. Luckily here at Kaplan Humboldt, we're good for 6 or 7 days, which is nice. As opposed to 4 hours at the other place, which is ridiculous. But anyways, let's go ahead and we're gonna look at our pages. We're gonna look at our week, let's see, week 12, I think we're at week 11. ANOVA data, here we go. So we can read this in. Let's go ahead. All right, so we've got our ANOVA data. Again, just our kind of framework where we've used previously to read in our R code. I'm going to actually use, well, we'll use this one here. You don't really need the filter. All right, so what does the question ask us to do? So we're going to be looking at how the number of cylinders, the type of transmission, the class of vehicle impact highway mileage. So let's go ahead and let's read in MPG. So we're going to go ahead, do something a little bit different. So let's do ahead MPG. Let's read that in, and we can see what we've got here. So I am going to take MPG and I'm going to pipe it. So I'm going to call it, again, I'm going to call mine R select. And I'm going to do MPG and I'm going to pipe this. And I'm going to select df underscore select. And then I'm going to do vars equals. And then we're going to do, so we need the, what is it, the number of cylinders? Number of cylinders, type transmission, class. So transmission, and then class. And then I'm also going to select, obviously, my housing effect highway mileage. So we're going to do a 3-way ANOVA because we have 3 variables: cylinder, transmission, class of vehicles. So we are going to put in cylinder here. So we're going to set our variables as factors. Although let's go ahead. We're going to ensure that this code does indeed work. We're going to do class as a factor. And then a numeric we're going to set as highway as numeric, and that's going to be the 4th column. Now, it's really, really important. So again, in this problem, when you're doing it on the exam, we have to ensure that we've correctly read in the data. Which means, so we're going to read in a variable that we created, right? So we are hoping to create a variable that has cylinder, transmission, class, and highway in that order. So let's look at our select. And we do. So when I bring out the first column, it's the cylinder. And the cylinder, I have 4-cylinder, 6-cylinder, 8-cylinder, and actually we can do summary of the data to kind of see what we have. So actually, let's do a summary of our data. Actually, we can do it once we've kind of read it in. So I'm going to bring in the first column, second column, third column, and then an as factor, as numeric. And then I'm going to get a summary of the data and see if this is correct. So we have 4-cylinder, 5-cylinder, 6-cylinder, 7-cylinder for cylinders. We have others for here, different classes here. So I know that for my cylinder, I need 1, 2, 3, 4. So I should expect 3 degrees of freedom in my ANOVA analysis. Now in the ANOVA, I'm going to set my data to the data that I put in the data frame. ARM data, ARAM data. And I'm going to go to highway, and I'm going to go, and now I'm going to do the full 3-way interaction. So I'm going to do cylinder plus trans plus class plus, I'm going to do cylinder trans plus I'm going to do trans class plus I'm going to do class trans plus I'm going to go down here cylinder trans three-way interaction class. So I'm going to complete that. I'm going to look at my summary of my two-way ANOVA, and we see that we have all of the combined interactions are not relevant, but all of these factors are actually critically important, and most importantly for cylinders, we have 3 degrees of freedom. Excellent. We can look at our eta squared, and we can see that cylinder and class are both big factors. Transmission, not so much. So we may really want to focus on these parameters, but let's go ahead and let's take a peek at, and again, we don't really care about these because they're very, very small. Interestingly, transmission has a small, but we'll see in the data set and how it looks like. So we're going to look at how highway, how does it vary versus cylinders, and then how does highway vary in terms of our transmission, and we're going to also copy and do this for how does it vary versus my class. So we can see some of the values here. So you see all these are very statistically significant. Let's look at this data set in a plot. So I'm going to take this data set, I'm going to look at on the x-axis, I'm going to look at cylinder, and then I'm going to look at highway here. So if I wanted to maximize my values, now 5 is an interesting one because I think there's only one set of data set, one piece of data here. So you can see 4 and 5 are different. So if I want to maximize my highway mileage, I'm going to use my four-cylinder vehicle. What about transmission? Let's see. So if I look at my transition, I've got different classes. I've got auto, 13, 14. So different types of auto versus manual transition, many of which are not statistically significant. So I can look over here. This is probably something we want to clean up in the data set. So yeah, you can see this is kind of messy. So if I wanted to maximize these values, it's not going to be as clear, and that's why you see kind of this small effect, right? Because there's not a single value which is really maximizing it. There's a lot of overlap in our game's HAL test where it shows not statistically significant. So there's only a few, and we can kind of point out, some of them like auto 13, auto 14. These are statistic, or actually, we don't even have the values to kind of compare those to. But auto AV to 13, it's showing it's not available. Auto AV to 14, that is statistically significant. You can look at the p-values, but it's not even comparing some of them because of, again, probably your lack of statistical values. You can see that reflected somewhat on the bar chart as well. Then finally, for class, we can see that for class, we do have, actually, we can see some differences, but there's actually 11 more parameters here. So again, difficult one to visualize. We can see that here. So visualization may be key. So for class, I can see I don't want here, the two-seater. I probably want something that's more like a compact, a mid-size, or a subcompact, and they all look like they overlap. So those 3 answers would be sufficient to maximize those values. Fantastic. That's how you want to approach those. Combine some plots, combine some words, and that's the end of your exam. Best of luck, and I'll see you on the exam. Thanks. Bye.